Thanks very much. It's wonderful to be here today, and I'm here representing the Burden Groundwater Network, which I co-chair with Tamiro in South Africa and Viviana from Italy. So as my previous speakers, so John Cherry, Jesus and Gabriel just now, I'm going to remind us all that we share a secret. In fact, I realise that IH should really be a secret society. We are the ones that know that groundwater and access to groundwater is what gives us sustainable livelihoods and good water security. We know it. It seems that a lot of other people don't seem to know it, but we do. We're a secret society, Bruce. But actually, in the past, people really knew it too. So the ancient Romans knew it, the Greeks knew it, the Celts knew it, and actually there's emerging evidence that Neolithic communities also knew that to increase their security, they should access groundwater. So what I'm going to talk to you today about, I'm going to start off talking about African rural water supply and what that means for security. I'm going to give some examples from the droughts that happened during the last major El Nino in 2015 and the following year. And then if I've got time, and I'll be getting kept to time, I'll then talk a little bit about the functionality of water points, how to keep water points working, and move on to looking at large-scale abstraction for agriculture. So this work that I'm going to talk to you about has mainly come out of BGS Research. We're working in about 24 countries at the moment. I lead our international groundwater research programme, so we're in about 24 countries, and a lot of this has been funded by a DFID programme called UPGROW, and a number of you in the audience are working on that programme as well. So I'm going to start off with rural water supply and groundwater and poverty in Africa. And the question here is, how can groundwater be used to improve water security for individual communities? So a lot of you will know about the Sustainable Development Goals. So these are the progress for the Sustainable Development Goals for water for sub-Saharan Africa. Now, these are a big change from the Millennium Development Goals. The Sustainable Development Goals have got much more stringent targets for water supply. So progress here for sub-Saharan Africa is very poor. If we look at the blue at the bottom, is it 27%? That's access to safe water, because now safe water means water delivered all year round to your compound, to your house, at good quality. And then even if we go to a basic service, which is an improved water supply within a 30-minute round journey of your compound, then still we're only over halfway in sub-Saharan Africa. And above that we have limited access, which means water from an improved source that's more than 30 minutes journey, and then other unimproved sources at the top. So the Sustainable Development Goals has really changed the boundaries and the context for us as hydrogeologists looking at access to water. So what does this mean? What does lack of access to water supply still mean? Well, it still means poor health. If you don't have a decent water supply, there's still many people who are getting a lot of water diseases. And there's, again, growing evidence that children with poor water quality in the first few years of their life, that will go on to impair their performance throughout their whole life. So it's not just about bouts of diarrhea or whatever, it's about long-term development of children. It also means a lot of time wasted. So there's still huge amounts of time wasted collecting water across sub-Saharan Africa. And it means children out of school, either collecting water or because hygiene and sanitation facilities aren't good enough to allow young women and girls to go to school. So still huge amount of impact for rural communities. And of course this burden falls mainly on women in these countries. So most of the burden being taken by them. So access to a good water supply, groundwater or reliable water, is the secret that really helps to unlock the potential in many of these communities. And it's something we all know in our secret society of IH. Now looking at the looking at these kind of stories or these evidence in a slightly different way. We did some work a few years ago with a really good clinical doctor in the UK, where we looked at infant mortality and not having access to clean water. So the bottom axis there is percentage of people within the country without access to clean water. And we found a very good relationship between infant mortality and not having clean water, even when you accounted for the other things like GDP and corruption and other things within the community. So the best thing that most countries can do to improve their health is to invest in safe, clean water supplies. That's still the case today, and even more so with the higher targets of the Sustainable Development Goals. So, from these previous slides, you'll realise that a lot of these, the benefits we get from water, isn't just contained in the SDG 6, which is the water one, but throughout the rest of them. The poverty, the no hunger, the equality. So, again, access to groundwater, it's not just about water supply, it's about so many other things which the international community has signed up to try and achieve. So it's important for us to realise it's not just about water, it's about many other things as well. So with that kind of introduction, I'll go back to the 3 questions that hydrogeologists love to ask about everything. First of all, if we look at an area, we want to work out, is there going to be groundwater there? If we're going to abstract it, how sustainable is it? And will it actually be safe to drink? What's the water quality like? And I'm going to run through for sub-Saharan Africa and try and answer some of these questions. Let's start looking at a very broad scale. So here's a map that we developed a number of years ago at a very high level to just look at what would be the likely yields if you sited a borehole well, so not if you drilled randomly, but if you sited a well, a borehole properly, what are the likely yields you would get? And we used this was a meta-analysis from all the published and grey literature we could get across Africa. And you realise that actually a lot of the rocks, even the crystalline basement, if you look pretty well, if you've got some good hydrogeologists and you put a borehole in, construct it in a good way, you're likely to get enough water for a hand pump. A hand pump needs about 0.2, 0.3 litres per second. And if you do a little bit of maths around about that, you realise that's a transmissivity of 1 metre squared per day. So that's a magic number for a lot of us as hydrogeologists. Transmissivity, 1 metre squared per day, which is very low, should be sufficient to sustain the yield of a hand pump. And a lot of our aquifers are able to do that. So we've been going into a lot more detail since this original kind of meta-analysis. And Marco Bianchi is going to talk later on today about some work we're doing in northern Ghana and Burkina Faso, where we've got about several thousand pumping tests, and we're looking at the distribution of transmissivity in a lot more detail. But here, if I can give you results, Marco, if you're here, the transmissivity is about 10, 12 meters squared per day, so great for rural water supply. Some other work we did just looking at reported yields from drilling logs in sort of more southern Eastern Africa. This was done by Lou Morris and Khalees Tindabagaya. We found that actually a lot of the drilling yields are again in the right ballpark figure for rural water supply. So it's looking promising. And already giving a talk today is Mike O'War from Uganda. He gave a talk yesterday where he's been analysing 1,000 pumping tests for Uganda. And I think in there there's maybe more problems with the transmissivity. A lot of it's maybe a bit lower than 1, so there's some other issues there. So in terms of groundwater availability, generally we can find enough water that will sustain a hand pump. But what about sustainability? What about groundwater recharge? Are these rural water supplies and maybe larger supplies across sub-Saharan Africa, are they going to be sustainable with climate change and increasing abstraction and such like? So I'm going to look at it in 3 different ways just now. First of all, we spent the last 5 years trying to collate lots of long-term hydrographs for across the continent. So there's many people involved in this. It was led by Mark Cuthbert and Richard Taylor. And we managed to get 13 multi-decadal long-term hydrographs. And it was quite interesting the way that the recharge occurred across these different areas. There were some areas, more humid areas, where you couldn't get any more recharge in. So basically they filled up every year. More rainfall means no more recharge because they're full up. In the semi-arid areas, we had slightly more complex relationships, but and then as you went more arid, what we found was that the importance of things like ENSO became much more important. So you might see a decline in groundwater levels for 10 years, 12 years, but then some big ENSO event comes in and groundwater levels might recover fully within that period. And that really reminds us how important it is to monitor for a long time. You know, sometimes we're lucky to get 3 years monitoring data, but if we can monitor for longer, and certainly multi-decadal, then it allows us to understand some of these climate effects. I think Matt might be talking about soon. And then we've looked at it in a different way as well, using the GRACE satellites, which have been so useful, looking at a much larger scale here. And I don't want you to see all the detail here, but in terms of the statistical significant trends across these sedimentary basins, the only long-term significant trends we could get was actually rising groundwater levels. And that's in the Sahel areas where there's been such land use change that's allowed there to be much more recharge in these areas. So no long-term evidence of depletion. That's hardly surprising because hand pumps aren't really taking out so much water. And then in southern Africa, we have a slightly more complex trend. It's a long-term trend that rises and falls and is just coupled with what the long-term rainfall is doing in this area. So these GRACE satellites, again, telling us here that there's not long-term depletion of groundwater, actually rising groundwater levels in parts of the Sahel due to land use change. And then we've been looking at it in a third way as well, which is looking at the residence times of groundwater using dissolved gases, so chlorofluorocarbons and sulfur-fluorohexate and such like, trying to understand the residence times of groundwater coming out of rural water supplies. And there's one of my co-workers there, Sefu Kebede, and top right there, looking hard at work there. And we've been working across 3 countries where we've been pumping groundwater and trying to measure the residence times. And this is with Peter Cook and Eddie Banks in Flinders in Australia. And what they've been telling us as well, if you've been used to looking at these sorts of graphs, this CFC along the bottom, SF6 up the top, and that, if it's down the bottom left-hand side, it means no modern recharge. It means it's very, very old water, pre the development of these gases, so 1950s. If it's at all up into the right-hand area, then it means there's some modern groundwater in the system. And what we found in this study, and several other studies that have been done, we've done some in Western Africa as well, is that majority of hand pumps, just about all of them, have modern groundwater within them. They are being recharged, and recharged quite significantly. So 3 bits of evidence about the sustainability, all telling us that the systems are being recharged, there's no long-term depletion, and actually long-term climate effects are really important with recharging the groundwater systems. So third question, water quality. Now there's been several studies showing that poor groundwater quality, particularly for pathogens. There's a World Bank study out for Ethiopia saying that most systems were contaminated. We decided to do a much more randomised trial across 3 countries. So we randomly chose water points and then we sampled them for water quality. It was just a one-off sample during the dry season. But what we found, this graph here on the bottom right, is that failures is up the left-hand side, so the percentage of sites that have failed is up the left-hand side, is that about 20% of sites failed, only 20%, and most of that was because of fecal contamination, and that's probably due to construction. So we can deal with it. We can deal with that by making sure that construction standards are slightly better. And in terms of the geogenic contamination, arsenic, fluoride, manganese and such like, it was down to about less than 10%. Now this was a randomised sample, so we didn't go into the areas that we know that are problems like the Rift or places where there's arsenic contamination. This was much more randomised. Of course there are other places where geogenic contamination is a major issue for rural water supply. But looking at this broader issue, it shouldn't hold people back as long as they make sure they're testing the water supply. So to answer these questions then that started off with, is groundwater available? Yeah, I think so, for rural water supply. How sustainable is it? Well, for rural water supply, pretty sustainable. Will it be safe to drink? If it's constructed well and as long as it's tested for geogenic contamination, the majority of the time, yes. So good news. Let me go on a little bit now to resilience to drought. How access to groundwater can make communities more resilient to drought. So this is some work we've been doing in the Ethiopian highlands, in the two waradas, in Kobo and Laigent, and they represent sort of more plain area. Kobo is down just off the escarpment, and Laigent is up in the more dissected plateau. And if those of you that remember the 1983 droughts, then Laigent is where the majority of people migrated from because they'd run out of water. So that was a real hotspot of issues for 1983. So what we've done the context for this study is that this area, the second graph in from the left there, you can see the big red area means the deficit in rainfall that happened during 2015. So basically they didn't get any rainfall in July. The rainfall in Ethiopia, in this part of Ethiopia, happens in July and August, and there was none in July at all. So rainfall really plummeted. And the bottom graph shows the long-term context of that. So the 1983 drought, El Nino on the left-hand side, and the one in 2015, you can see is almost similar to what happened in 1983. So a very severe drought that happened in Ethiopia then. So what we did was we instrumented about 30 different water points, boreholes, hand-dug wells, and springs. And what we're seeing there is the hydrographs and the rainfall response. And again, no surprise to our secret society, the results here. The borehole is on the top, and the borehole performed really well throughout the drought. And what we did was we calculated the recovery times every night for the boreholes when it was being used, and the recovery was exactly the same throughout the year, throughout the season. So in the drought, it recovered at the same rate as it did during the wet season. For the hand-dug wells, which is the next one down, the recovery took much longer, and you can see the graph, the middle graph there, actually bottoms out at the bottom of that hand-dug well, so it became unsustainable. And the spring was similar, became fairly unsustainable. So no surprise to our secret society. But what we did do as part of this then was do a lot of detailed community discussions. We had some focus group discussions. We spoke to health workers, we spoke to the water officials to try and work out what did that lack of water mean for your community. So we went to communities that were using hand-dug wells and springs mainly, and one or two with boreholes. I'm going to show you a result which is trying to summarise all that kind of social science data into one sort of table. I'm just going to, I'll talk you through them a little bit. The colours hopefully shall help. So we looked at how much water people were collecting during the drought, how long it took them to collect it, which is the next column along, then how their behaviour changed, what did they have to do, then what the impacts might be in terms of conflict, or did they miss meals or such like, and then we looked at the health impacts. And I'll show you a graph of the first two things there, which is really about the amount of water they were collecting every day and the time for daily collection. And see how even in the wet season they were collecting about between 10 and 20 litres. In the dry season, a normal dry season, most people are collecting less than 10 litres per capita per day. And then during the drought, collecting down to a baseline of about 3 litres, which you can't really survive on collecting less than that. So no hygiene, no water used for hygiene, a lot of time collecting water, so 10 hours or more. And the impacts on the community were astounding for a lot of them. A huge change in behaviour. People missed meals. There was no agriculture done in many of these communities. So the red at the bottom there is the kind of severe impact. So in these communities, people were missing 2 meals a day. They were changing what they ate so that it didn't need any water. And there was a lot of conflict. So men having to collect water because of the conflict that was happening. In fact, there was one community we went to where the health people said there were 60 60 people with broken skulls during that time because of a big riot. So a huge amount of water insecurity because they didn't have access to water. And that brings us back a little bit to the Sustainable Development Goals. Safely managed water is brilliant, water in your compound, but for these people, even a hand pump that was more than 30 minutes away would have been a massive improvement for them. So I think we've got to keep sight of that as a community, that we don't just go for the gold standard, but we make sure that there is this basic or even slightly below basic provision. So moving on to functionality. So keeping these water points functioning. And again, we've had the luxury of doing quite a nice study, a long study on looking at the functionality of water points in 3 countries as part of UPGROW. So the first figure is 82%. So that's if you go and measure functionality in a lot of these countries, then functionality around about 80%. If you go to the water points and see if they're working. So that matches up with the government statistics and matches up with our survey here that we had done as well. But then if you look at it in slightly more detail, because you try and work out, well, what does a functional water point mean? And we've been trying to explore that. If you take functional to mean gives the amount of water it's meant to give for the hand pump and works for 11 months of the year, then you get a much more different figure. And we found that only 45% of water points in these countries are actually giving the amount of water they're meant to be giving from the hand pump and reliably for more than 11 months of the year. So what impact did that have on communities? We had some social scientists, we've been doing a lot of work in conjunction with social scientists. So they spent about 6 to 12 months longitudinal studies in 12 communities, having people taking notes every day. And here's just a couple of the quotes that I wanted to read out to you here that were directly from villagers in Uganda. And here's one. The borehole from our neighbouring village broke down. This means that people from other villages came to draw water. So people coming in to take water from the community. The borehole is developing faults due to overuse. This is because we're already serving 2,000 people. And these are not isolated quotes. We were getting these time and time again. The huge demand being put on water points. And we only got to understand that because our researchers from Makerere University went out and actually spent so much time in these communities. And then the last one, everything concerning conflict comes in the dry season when the other sources are dry, and yet the borehole brings little water, which causes a lot of confusion, and no one likes to be in the queue. People fight. So reasons for low functionality. Now this is a talk all on its own, and I've only got 3 or 4 minutes left, so I'm not going to really talk about this at all. But we're in the process of we've taken apart 150 water points, put them back together again, and we're trying to understand are the systematic reasons for them. So hydrogeology is part of it. Sometimes people are putting boreholes in the wrong place. There is some engineering issues with it, but a lot of it is about this kind of social technical interface, which is so important. And us as hydrogeologists working in this area need to be working with social scientists and others to understand this kind of interface. The interface between management and the groundwater source itself. Just to highlight that maintenance, of all the things we looked at, just getting maintenance, affordable maintenance, is the key. And there's a lot of really good people and models now looking at different ways of doing community management. Community management plus, which allows there to be more access to maintenance and such like. So maybe in the last couple of minutes, I'll run through some stuff on agriculture. Because I've just been talking about rural water supply, which is looking at basic services for people. But then what about much larger uses of water? This really hasn't got going in Africa. There's a little bit maybe in the Upper Wash Basin in Ethiopia, maybe northern Nigeria with the pivot irrigation, and then a lot of interest in much more community-based irrigation. Do we have lessons from South Asia? So the Indo-Gangetic Basin Aquifer, the world's most productive groundwater source. Huge demand on groundwater here. And most importantly, a lot of sugar there for everybody. Know Irn-Bru? I'm from Scotland. We do 2 drinks. We do whiskey, it's very nice. We do Irn-Bru, which is very nice too. So we're a bit concerned that Brexit might mean you don't have access to Irn-Bru, but I'm sure we'll try and make sure that we get Irn-Bru around the world. Anyway, lots of sugar. That's my Brexit joke. Climate change effects in this area, there's a lot of direct climate change effects. Is it less rainfall? Interesting stuff to do with the monsoon. Also issues about melting glaciers, how that will affect the rivers. And this narrative of depletion, which Matt, I'm sure, will talk to us about, this great evidence about the depleting groundwater resources because of the huge amount of water. I just want to talk through 3 maps of this aquifer, which I hope explain what's going on, and then I'll finish. First is the abstraction. Look at how high that abstraction is, over 500 millimetres of abstraction. So irrigating 3 times a year and such like. Oh, I went the wrong way. And look at the depletion. So this is from in situ measurements, and we had a lot of friends in India putting all these data together. And see how the depletion is very focused to the parts of the Punjab. And see also you have rising groundwater levels next to falling groundwater levels due to the access of the canal. So depletion is an issue. It's probably not stopping the large farmers farming. There are issues to do with quality. But then look at the water quality. Big issue here is salinity. That's why irrigation and livelihoods in the Indus and in Pakistan are so difficult. It's because of the salinity. The salinity is not due to falling groundwater levels, it's due to rising groundwater levels. That's probably the main issue here for sustainability, is the water quality. So we need to keep our eye on water quality as well as on water quantity. So I'll just skip on to the end here. So lots of lessons on access to water and poverty and sustainable livelihoods. At the Burden Network, we're putting together a book trying to capture examples of how groundwater has affected people's livelihoods. If you've got any ideas, come along to our Burden session later on today. So just in summary, groundwater, fundamental for water security, we know that. Further development of groundwater is so important for the Sustainable Development Goals. We need to make sure we're developing groundwater. And we need to massively invest in basic services, even if they're maybe far from a community, to allow them to be resilient through drought. We need to emphasise more functionality, and we need to work with social scientists, we need to work with others to try and understand how to keep water points functioning. And so many good examples of groundwater leading to economic growth and how that improves the local autonomy of people. And just at the bottom there is all the many myriads of people who've helped with all this research here, so just to honour them, thank you for allowing me to use your slides and being involved in all the research. Thanks very much.